Hey, Alex, I appreciate somebody showing up.
Hey, Miss Sparks.
How are you?
I'm good. How are you?
I'm doing great. I was worried nobody was going to come hang out with me today. So I appreciate you showing up. um, can you hear me?
Yeah.
Okay. All right. Well, I was just going to go over homework number 4. Did you have any specific questions before I start?
No.
Okay. So I'm just going to work through if that's okay with you.
Yeah.
All right, great. I appreciate it. Um, it makes it so much easier when somebody shows up, so I'm not just talking to the air. So you are a true blessing to me today. Thank you. All right, so which trig functions are positive for angles terminating in quadrant 4? So I usually just draw that, well, when my stylus works, I draw where all trig functions are positive in quadrant 1. Only all students, only sine is positive in quadrant 2. Only tangent is positive in quadrant 3. And only cosine is positive in quadrant 4. So all students take calculus. So which trig functions are positive for angles terminating in quadrant 4? So if you look at your little chart here, that's going to be cosine only. And the reason that cosine only is that is your x your x coordinate for your ordered pairs on the unit circle. So that's why cosine, and x is positive, is the only thing that's positive in quadrant 4. Which trig functions are negative for angles terminating in quadrant 2? So we're looking at quadrant 2, and the only thing that's positive is sine. So that means cosine and tangent are going to be negative. On number 3, if cosine is less than 0, which quadrants could the terminal side of theta lie? So that means it's going to be negative. So we're looking for where cosine is negative. So it's positive in quadrant 1. It's positive in quadrant 4. So the only place that it could be negative is quadrant 2 and quadrant 3. If cosecant is greater than 0, and cosecant is 1 over sine theta, and it's greater than 0, which quadrant could the terminal side of theta lie? Well, just because it's the reciprocal of sine, that's not going to change anything about the positive or the negative. The sign is going to stay the same, no pun intended on that one. So I'm looking for wherever sine is positive or greater than 0. So that would be quadrant 1, because all trig functions are positive in quadrant 1. And it's also positive in quadrant 2. If tan is less than 0, meaning tan is negative, and secant is greater than 0, and secant theta is the reciprocal of 1 over cosine theta. So we're looking for where this is positive and this is negative. So let's figure out where tan is negative first. Well, tan is positive in quadrant 1 and quadrant 3. So that means it's going to be negative in quadrant 2 and quadrant 3. Okay, so this is where it's negative. And secant, which is 1 over cosine, we're looking for where it's positive. So where is cosine positive? It's quadrant 1 and quadrant 4. So I feel like I just did something wrong.
I think tangent's negative in quadrants 2 and quadrants 4.
Oh, bless you. You're right. Bless you, bless you, bless you. I knew I did something wrong. Bless you. I put down where it was positive instead of negative. Okay, and then bless you for helping me out. And then that helps me now. That cosine is positive in quadrant 1 and quadrant 4. So we have to look what is the only quadrant they both have in common is quadrant 4. And so that's your final answer is quadrant 4. All right. Thank you. So if sine, and I did that one yesterday in class. So if sine is less than 0, so that means where is sine negative? So that's going to be quadrants. Where is it? I have to flip my brain here. So if it's positive, if sine is positive in quadrant 1 and 2, it's going to be negative in quadrant 3 and 4. Did I do that right? And then if cotangent is negative as well, cotangent is positive in 1 and 3, so it's negative in 2 and 4. So the only answer that's in common for both of them is quadrant 4. So that's your answer. I need to get my second cup of coffee. Okay, so sine 60. Well, I pulled up the unit circle also on this to be able to help us out on that, to look at how we can do this a couple of ways. So a couple things that we want to do is I'm going to go ahead and draw the reference angle for sine 60. And what we would know is that this is going to be the long walk, short walk. So that's going to be 1/2, and this is going to be root 3 over 2. So the y coordinate is this one, and that's sine. So our answer is root 3 over 2, but I also wanted to show it on the unit circle. So sine cosine theta is x, sine theta is y, and tangent is y over x. So you can see if it's asking us sine 60, you look on your unit circle and there's sine 60, and sine is the y coordinate. So that's your answer. So a couple different ways to look at that. Cosine 225. So 225. So if you are using your unit circle, you could go to 225. And cosine 225, cosine is the x coordinate. So negative root 2 over 2. The other way that you could do that is to actually draw your unit circle and see that 225 is down here. And that's going to be your 45, 45, 90 degree angle. And both legs are the same. But you also want to take into consideration that that is quadrant 3 or quadrant 4 where cosine is negative. No, quadrant 3 where cosine is negative. Quadrant 3 where cosine is negative. Tan 330. So tan is y over x. So if we go over to our unit circle and look for 330, here's tan. So we've got negative 1/2 over root 3 over 2. Which, remember, when you divide, you have a complex fraction and you divide that, you only have to deal with the numerators because the denominators would cancel. So you've got negative 1 over root 3, which we can't leave it like that. We have to rationalize that denominator. So that gives me root 3 over 3, but negative. So my final answer is this. Cotangent 150 degrees. So cotangent is the inverse of tangent. So that's going to be x over y instead of y over x. So now I'm going to go over to the unit circle and look for 150. There she is. And instead of y over x, I have x over y. So I'm going to have negative root 3 over 2 all over 1/2. So once again, my denominators, when you have a complex fraction and the denominators are the same, you only have to deal with the numerator. So that's going to give me negative root 3 over 1. And then that simplifies to negative root 3. And that's my final answer. Okay, secant. Secant is 1 over cosine because it's the reciprocal of cosine. So if I go to my unit circle and I look for 135, cosine is the x variable. So I have 1 over negative root 2 over 2. So if I keep flip change, that's going to give me, basically, I'm going to take the inverse of that. That's going to be 2 over negative 2 over root 2. I have to rationalize that denominator. So that gives me 2 over 2 times root 2 over 2. And that's all negative. And the 2's cancel. So my final answer is negative root 2. Tan 210. So I can go to my unit circle and I can see the coordinates are negative 3 over 2. Negative root 3 over 2 and negative 1/2. So that's y over x. So I have negative 1/2 over negative root 3 over 2. My denominators would cancel, so I have negative 1 over negative root 3. I have to rationalize that denominator. So I end with, I've got a negative divided by a negative, and then I end with root 3 over 3. And it's positive because a negative divided by a negative is positive. Okay, 270. That's right down here. That's one of those quadrantal angles. And we're looking for secant. And secant is 1 over cosine. So if I look at my unit circle.
Bye, love you.
Bye, love you. Good luck on your presentation. Cosine is 0. So that's going to be 1 over 0. And that is a no-no in math. So this one is undefined. Cosecant 315. That's 1 over sine theta. Do you want to do any of these? All of a sudden I had this moment that I'm like, maybe she would like to be doing these. Are you just following along? Oh, and Anna's here. Do you guys want to do any of these? Like, I'm just hogging the show here. Would you guys like to do some? Would that help you guys?
I'm good just following along, but if Alex
Yeah.
wants to do them, that's good.
Okay. All right. Is this making more sense?
Yes.
Yeah.
Okay. Do you like, okay, let me ask you, do you like when I actually draw the reference angle, or do you like using the unit circle?
I just use the unit circle.
That's
Okay.
what I do too.
Okay. Are you getting the connection between the unit circle and the triangles?
Yeah.
Yes.
Okay, good. Okay, 1 over sine theta.
You know where my coffee is.
Hold on, guys. Okay. Yes, please. All right. So, well, just stop me if y'all want to play along at any point, okay? Okay, so cosecant 1 over sine theta. So we'll go back to the unit circle and look for 315. We're looking for sine, and sine is the y variable. So that's going to be 1 over root 2 over 2, and it's negative. So we'll keep flip change. So that gives me, I'm going to erase some of this stuff so I have room. These boxes are little. Let me see if I can make it a little bigger. Ah. No, Finn. 1. And that's negative. So if I keep flip change, that's going to give me 2 over root 2. And I've got to rationalize the denominator. So that's going to give me 2 times root 2 over 2. And the 2's cancel. So that's going to be 2. I'm sorry. Root 2. So cosecant 315 is negative root 2. All right, sine 240. So we're looking for 240, and we're looking for sine, and that's the y coordinate. So that's going to be negative root 3 over 2. Tangent, 7 pi over 6. 7 pi over 6 is right here. It's not real clear on this one. Maybe y'all's is clear. And we're looking for, what we're looking for? Tangent. So that's going to be y over x So we have, I feel like we did this earlier, did we? So basically, it's number 12. Because if you look at 210 and 7 pi over 6, they're the same exact same angle with just measured differently, one in degrees, one in radians, and we already had tan 210. So the answer to number 16 is number 12. Does it help y'all though if I work them out?
I'm okay because it's the same thing basically.
Okay.
Yeah.
How about you? Okay, good. All right. So, and sometimes it just helps you to familiarize yourself with like knowing that 210 and 7 pi over 6 is the same thing too. So when you do the unit circle quizzes, which it's just degrees on Monday. So, and I'm going to go over that with you guys too. And this is the quadrant where all tangent is positive. Tangent is the only trig function that is positive. So our answer is positive. Okay, cosine 3 pi over 4. So we're going to look for 3 pi over 4 on our unit circle, which is right there. It's the same as 135. But cosine is the x coordinate. So it's negative root 2 over 2. Cosecant, 5 pi over 3. Cosecant is the same as 1 over sine. So we're looking for where 5 pi, the measure of 5 pi over 3, which that's 300 degrees also. It's this angle right here. And we were looking for cosecant, which is 1 over sine. So that means we're looking for the y value. So 1 over negative, because the y or sine is negative in quadrant 4, negative root 3 over 2. And if I keep flip change, that gives me 2 over root 3. I have to rationalize my denominator. So that gives me 2 times root 3 over 3, and it's negative. So that's cosecant 5 pi over 3. Now I'm looking for sine pi over 6. That's the same measure of 30, and sine is y, so that's 1/2. And then cotangent 5 pi over 6, and that's here. And cotangent, instead of being y over x like tangent is, it's the reciprocal of that. So it's x over y. So I'm going to have negative root 3 over 2 over 1/2. And remember, with a complex fraction, when the denominators are the same, the denominators cancel, and then you're just dealing with the numerators. So in this case, it's going to be negative root 3 over 1, which then just simplifies to negative root 3. Oh, we had that one too because we did 150, right? Did we do 150 earlier? Yeah. So technically, that was the same answer as number 10. I just noticed that part. Okay, so secant, 11 pi over 6. And secant is 1 over cosine. So we're looking for the x variable at 11 pi over 6. So that's this one right here because there's 11 pi over 6. So it's root 3 over 2 but we keep flip change. So that's going to be 2 over root 3. So I have to rationalize that. Oops, sorry, that was messy. So there it is. That's your final answer.
Would that be negative or is it still a positive?
It's still positive because it's cosine.
Okay.
Because all the x variables, good question though, for clarification, all your x's on this are positive
Okay, that makes sense.
on that side. In quadrant 4, our cosine is positive.
Okay.
All right. Any questions about this part of the homework?
No.
I'm
Okay.
good. Thank you.
Okay. All right. Now, Monday, when we do a unit circle quiz over degrees only, I don't think this will be too bad for you guys, but let's just run through a good way to kind of take a look at it and break it down. A lot of times, what I try to do is you do your 0 and 360 at your starting point. Okay? Because you know, okay, that's I'm either going to be starting at 0 or ending if I've made a complete circle at 360. So that one's fairly easy because you know that there's 360 degrees. So I try to fill in those points first. So 0, and then you know a right angle is 90, and then a straight line is 180. And then you're going to add 90 to 180 to get your 270. So I would get my quadrantal angles filled in first in taking that quiz. Does that make sense?
Yes.
Okay. So then once you get your quadrantal angles filled in, what I would do next then is know that there's always this bigger space right here between 0 and this one. So it jumps to 30, then goes by increments of 15 3 times. Or yeah, twice, basically, I guess you would say. So you've got 30, 45, 60 right here. So these are all increments of 16, which when you kind of get into radians, you're going to see that's going to be just a pi over 6 measurement. Or yeah, well, actually, technically pi over 12. But we'll break that down when I do radians in Tuesday's lab. But so once you do that 15, 15, then when you get to 60, you jump 30 to 90. Then you jump 30 to 120, and then these are 15. Does that make sense?
Yes.
Okay. Then you'll go back to 30, and then 30 again, and then each of these are 15. So you would go just add 30 to 180 this time to get your 210. And then add 15 here, 15 here, and then you go back to 30, adding 30. And then you'll add 30 here. And then you're going to go back to adding 15 and 15 and then 30. So it's like 30, 15, 15, 30, 30, 15, 15, 30, 30. Does that make sense? How you're adding those? I don't know if that helps y'all break it down or not, or maybe you're just good at memorizing all that stuff. But that's kind of the pattern.
That helped a lot. Thank you.
Yeah.
Did it?
Mhm.
Oh, praise God. It just helps me to see a pattern. So, and that's how that roll, that's how that goes out. It's just so much easier that way. And so then on Tuesday's lab, I'll show y'all kind of the fractional, and I know how much y'all have fractions, but I'll show you how radians move with a pattern.
Okay.
All right. So only degrees on Monday. So not too foggy after Easter candy. Are there any other questions on any of the worksheets that we've done so far? Angles of elevation, angles of depression, the 45, 45, 90 triangles, any of that stuff.
I had a question, but I'm trying to find the worksheet.
Okay, sweetie. It'll take me a minute to find it too, so. But I'm here for you guys this morning till 10:30 or 11, however long y'all need me. Ask as many questions as you need to.
I think I'm good, but thank you.
Thank you so much for coming. I appreciate it. It's so much nicer when there's people in math lab with me and I'm not by myself. So bless you. I hope you have a happy Easter, Alex.
You too.
Take care. Bye-bye.
Bye.
So for on the take home quiz, there's a section number 16 and 17. And like on one of our worksheets we never got to it in class, so I don't really know how to do it.
Let me look for it, okay?
Oh, worksheet homework 3, 19 through 21.
Okay. Why don't I do some of those? Is that good with you?
Yeah.
I thought we had gotten to them, so I'm really sorry.
Oh no, you're fine.
So I'm going to go back to homework 3. This was it, right?
Yes.
But it was more like, yeah, you said 19, 20, and 21, right?
Yes.
Okay, cool. Okay. Sketch the angle in standard form whose terminal side passes. Oh, you know what? I won't be able to sketch it here until I open it with Cami. So I better do that. Sorry. Sketch the angle in standard form whose terminal side passes through the given point and find the exact value for each trigonometric function. So what we're looking at, we've got a -5, 12 point. So basically I would be going over 5 and then up 12. So probably, like way up here somewhere. Well, it's not letting, there we go. Wasn't letting me change to drawing, Does that make sense?
Yes.
Okay, so you kind of draw your angle. Nice straight line. Isn't that beautiful? Okay, so this would be 12 and this would be 5. And then your right angle would be here and your reference would be here. So your theta, when they're talking about that, is always this angle right here. That's your theta. Can you even tell that's a theta? I'm so sorry. Oh, maybe I should try that again so that it looks a little better. I'm going to try something. Praise the Lord. That's what I need to start doing. That looks better, don't you think?
Yeah.
Okay. So there's my reference angle and there's my theta, sort of. It's not much better, but that's theta. We'll pretend that's theta. So that means that this is sine and cosine, or you've got your, this is going to be opposite over, and this is adjacent, right? But we're missing what side?
The hypotenuse.
Yeah, good job. So we have to solve for that with what? A squared plus B squared equals C squared, right?
Yes.
To find that angle measure. So I'm looking for my calculator. I'm sorry. I can't do some of these in my head. So I was going to come over here and just pull up. Pull up my online calculator or use my phone. So we have 5 squared plus 12 squared, or it's -5, but it's going to end up being equals, and then whatever this is, like the C squared. So 25 plus 144. Oh, I can do this one in my head. I was thinking I couldn't. So then I have 169 and 160. I can do all of that in my head. So C equals 13. So we've got 13. So now really all we have to do is sine is SOHCAHTOA. Remember, so good old SOHCAHTOA. SOHCAHTOA. So now that we have all of our measures, we can just fill in what we know. So sine is opposite over hypotenuse, which that's going to be 12 over 13. Right?
Yes.
And cosecant is the reciprocal of that. So 13 over 12. And cosine is adjacent over hypotenuse, which that's going to be 5 over 13, right?
Mm-hmm.
Does that make sense?
Yes, that makes sense.
Oh, and wait. Yes. Some of these are negative. So my bad. That's negative because you've got to remember that that's negative.
Oh, okay.
Okay?
So
I
the
should've
5
wrote-
is negative?
Yes, ma'am.
Okay.
Because you're going over on the other side. From the origin, you're going left.
Okay.
So then the reciprocal of that is 13 over -5. And then tangent is opposite over adjacent. And cotangent is adjacent over opposite.
Okay. I think I'm good on that section.
Okay, well, I don't mind doing the other two if you want to.
I guess, yeah, one more would probably be good.
Okay, just to make sure, because if this one turns out weirder. So you've got over 2, up 8. So you'd be right here. I'm going to try and draw better lines this time for you, Anna. Not much better.
That's okay. Mine are bad too. So.
Oh, thanks for making me feel better about it. So this is going to be 2, 8. So that means this is 2 and this is 8. And this is your theta angle or your reference angle. And then this is your right angle. So we still need to know 2 squared plus 8 squared equals C squared. So we still need to know the measure of that line right there. So 4 plus 64 equals C. So 68, equals C squared, my bad. And so I got to take the square root of both of those. That's another reason why I wanted to do one of these, because then you've got to do your factor tree. And I like the birthday cake. Does that offend you?
No.
You're okay with that? 34 and then 2, and that's 17. So I've got 2 times root 7 equals C. So my opposite equals 8, adjacent equals 2, and my hypotenuse equals 2 times root 17. So sine is opposite over hypotenuse, which is going to be 8 over 2 root 17, which means I have to, I know I did that wrong, didn't I? Did I do that wrong? No, I'm good. But I have to rationalize that. And I can kind of reduce at the same time because that's just going to be 4 over root 17, right?
Yes.
So now I have to rationalize root 17. So my final answer is going to be 4. Let me see if I can make this a little bigger. Not that that's really going to help me at this point. 4 root 17 over 17 for that one. I want to go back to my simplest form before I flip it, because remember, cosecant is the inverse of it, but always go back to your simplest, like the one where you began. So you're going to have 2 root 17 over 8. Does that make sense when I say go back to the original?
Yes.
Okay. So that's going to be root 17 over 4. And then cosine is adjacent over hypotenuse. So that's going to be 2 over 2 root 17. And the 2's would cancel, but I still have to rationalize that denominator. So that's going to be root 17 over 17. And the reciprocal of that, going back to the original simpler version, I would have 2 root 17 over 2. And the 2's cancel. So that gives me root 17. And then tangent is opposite over adjacent, much prettier. So that reduces to 4. And cotangent, being the reciprocal of that, is 1 over 4. And I don't mind walking through number 21 if you would like.
I think I'm good on that one.
Okay. Do you have any other questions?
I think that's it. Thank you, though.
Oh, no problem. And remember on number 21 to keep any place that you're using that 6 as a negative
Okay.
in your answer. Okay?
Thank you.
No problem. Because that's going to be over 3 and down 6. So your point's going to be somewhere down here. Okay?
Yes.
And that should help with those on the quiz that are like that. Was there anything else on the quiz that you that you could reference back to a homework? Because I don't mind referencing back to a homework if you want to just take a look at it real quick. I'll wait here for you.
Okay.
Or you feel pretty good.
Number 15. I know there was one on a homework. I'll find it.
Okay. Because I don't mind helping with that at all. If I can go back and reference.
Okay. Braden and Bryson just got here, so I don't know if they have any questions while I look.
Oh, okay. Thank you for letting me know, because I can't ever see. Okay, Braden and Bryson, what I am doing is if you have any questions on, I went all the way through homework 4. So if you have questions on that, you can go back and watch the beginning. If you have, and now I went back to, I think, what were we working on? Anna, homework 3?
Yes.
Okay, we are working on some on homework 3. If you have any questions on homework 1, 2, 3, or 4, I can help with those. So if there's something like that you have on the quiz that you could reference a homework, I can help with those. I just cannot help with the quiz.
Like for homework one, I was watching the Ed puzzle, and when it got to number 9, um, it was doing the find all 6 trig ratios for theta shown in the triangle below. And I was trying to like do the one for the quiz or whatever, but I was just like confused with like the sine, cosine, tangent, and then code CSC, SEC, and COT. Like I forgot what those are. And then
They're
code
the
switching.
reciprocal.
What?
They're
Oh,
the okay. So, so like okay, we can even reference this a little bit. But I was trying to find if there was any place. Did we have to do all 6? Oh, on homework 1. On homework 1, let me pull that up. We had to do all 6 on, Lord Jesus, please help me think, on number 7 and 8.
as well as 9 too, because I was looking at number 9.
Yes, number 9 and 10, you had to too, given one particular one.
Yeah.
You're right. All right, so let me find homework 1 and pull that up.
I'm just like really lost for like number 1 because it's, I don't know, like the way I explained it in the video is kind of confusing to me.
Okay. Well, maybe if I walk through this, it'll help. Okay, buddy?
Okay.
I don't even remember what number 1 on the quiz looks like. So it looks, what would you say it, oh, I'm glad I scribbled all over my paper.
Oh, wow.
Okay, so I definitely did this in math lab.
It
So I
looks
can,
like number 7.
it looks like number 7.
Yeah. But instead of there being like the 5 or whatever, like the hypotenuse is shown and that back angle isn't shown.
Okay, so
But I figured that one out. I figured the back angle out. So like I have all 3 angles.
well, you don't really, are you supposed to find the angles or are you just supposed to find the trig functions?
Find the values of the 6 trig functions for angle
Okay,
theta.
so you only need sides.
Yeah, that's like, I mean, not angle, sides. I have all sides.
Oh, okay. All right. So
My
once
bad.
you have all sides, so basically it looks a little more like number 8 because number 8 has the hypotenuse given.
Well, it didn't have, it had the hypotenuse and the bottom angle shown. It did not have, like where the 5 is on number 7.
Uh-huh.
That's the angle that was, or the side that was not shown. And so like you had to like figure it out.
You have 2 sides though, right?
Yeah.
Okay. So one is going to either be adjacent or opposite.
Okay.
You see what I'm saying?
No.
Okay.
So like
If you
12.
have an hypotenuse given, okay, let's look at number 8. I'm going to erase everything on number 8 from the homework, okay?
Okay.
Would you say, let me erase all of this. Would you say on there, you have the hypotenuse given because
Yeah.
you know that the right angle is opposite it. And so you've got legs. Were you given the leg opposite of the theta angle or the leg adjacent to the theta angle?
I was
Like this on number 12. Oh, it's not writing for me. This is very sad. My computer locked up. I'm going to try to open it again and see if it opens better for me. Because basically you use the Pythagorean theorem to find all of your sides. Okay?
Yeah, I have all my sides, is what I'm saying.
Okay, you've got all of your sides.
I'm confused
So
on how to do like.
now write SOHCAHTOA. You remember what SOHCAHTOA is? So remember Miss Sparks wrote it right down here. SOHCAHTOA. So opposite over hypotenuse. So this side is opposite. This side is adjacent.
Okay.
So once you get all of your sides, so for this one, I am missing the opposite side. I don't know what this side is. So I've got x squared plus 12 squared equals 16 squared. Right?
Yeah.
So I've got 144 equals 256. Well, x squared plus 144. So I subtract from both sides, and I get x squared equals 112. Then I basically factor that all the way out and pull out all of my perfect squares, which 16 is going to be one of them. 16 times 7. So that's going to be 4 root 7. So that's
I'm
this
just
side
mainly
right here.
confused on is that cosecant and then
Okay.
secant and then
Okay, see how mine are written here? Sine is here.
yeah.
Cosecant, you just flip it.
So
So let's say look, it's easier to see on number 7. See how sine is 12 over 13 on number 7?
so you just flip it basically.
13 over 12.
So you're just flipping it
Cosine
for
is
every
5.
single one.
Yes. But if you
Oh.
get a radical in the denominator, like down here on cotangent, there's a radical in the denominator. You have to rationalize that denominator.
What does that mean?
Rationalizing the denominator,
Is that where you
it's
multiply
worked
everything
out
out?
right here. Huh?
Is that where you multiply the?
Yeah. Yeah, because you can't have a radical in the denominator,
Okay.
right?
Correct. So.
All right.
Okay. And then if you go to the back page, I think it's number 10.
Okay. Okay, so cosecant, go back over here. Cosecant is what? 1 over sine, or the reciprocal of sine.
Yeah, well,
So
my question is just like,
see how this is root 7 over 2? If this is the reciprocal of that, then wouldn't you just flip this to be that?
well, like for number 2 and 3 on the actual quiz,
Uh-huh.
it's got like this kind of a dealio, but it's if tan theta equals 2/7, find the remaining trigonometric blah 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 functions.
Uh-huh.
So you'd put in 2/7 for tan, and then that would mean that you
Well,
have to make
what
make
is
your
tan? What is
Huh?
tan? What
tan
is
is
tan first?
tangent
Yes,
or
what
opposite
is
over
tangent?
adjacent. Opposite over
It's-
adjacent.
Okay. So opposite
Then-
over adjacent. So it's opposite over adjacent.
Correct. So
So
then you make a
is
triangle and
that
you have to like
is that the hypotenuse?
no.
Okay, how would I get the hypotenuse?
You do 2 squared, 7 squared equals c squared. The Pythagorean theorem.
Correct. And that would give me all of my sides. And once I have all of my sides, I can do every trigonometric ratio, can I?
Yes.
Because that's all I need. Does that help?
Yes, ma'am, it does.
Okay, good.
But like when I have one, or never mind. Yeah. So I figured that out. There, you can answer Anna's question because she's been waiting a little bit. No.
Okay. Anna, what was your question? Did you find it, honey?
Yes, it was actually number 17 and 18 on the same worksheet we had pulled up. The homework 3.
Oh, okay. Coterminal angles for 5 pi over 18.
Like,
And
I
then
know
what
how
the
to,
reference
mhm.
angles
I
are.
know how to find it like when there's a degree, like on 13 through 16, but when it's like it has pi in it, I'm just kind of confused.
Okay. We did this one a couple ways in class. And I think, if I'm not mistaken, y'all loved the calculator way because you didn't like Miss Sparks' um, uh, doubling of the denominator. Do you remember that now? Does that start to ring a bell a little bit?
I just
You were
forgot
like,
to
oh,
put it in
Miss
the
Sparks,
calculator.
you're a geek with those fractions. And so on number 7, let's see if I can remember the calculator way because I kind of default to the. So, how many angles are we supposed to give? I can't remember. Oh, give 2 coterminal angles. Oh, one positive, one negative, and then the reference angle. So 5 pi over 18. So what you want to do on that, what I do is do remember what you're looking for is, remember, 2 pi is a full circle. It's the equivalent of your 360. 2 pi is. So 2 pi with a denominator of 18 would be 36 pi over 18. Does that make sense?
Mm-hmm.
So you
Miss
would add it.
Clark- I'm sorry.
Yeah. Yes.
No, it's okay. Finish. You can finish. My bad.
So if I'm not mistaken, I think what she did was 5 divided by 18. And then I think she oh, wait, no, she did parentheses 5 divided by 18, close parentheses, plus 2. And then I think she did math, enter, enter.
Okay. Wait, can you say that again? Sorry.
Yeah. Well, I was just making sure I did it right. I had to,
Okay.
because I do it old school and I don't do the, it's, you enter this 5 divided by 18 plus 2, and then hit math, enter, enter.
Oh, okay. Yeah.
Do you remember that now?
Yes.
And then then you need to make sure you get a negative one. And in this case, you will. Why did Bryson leave me?
I don't know.
Was I boring? 5
No,
divided
I
by
didn't think so.
18. I'm sorry, what'd you say?
I said I didn't think so.
Okay, well, bless you. Math, enter, enter. So if you do the minus, so my coterminals are 41 pi over 18 and negative 31 pi over 18. So if we think about where 5 pi over 18 is, remember that this is going, if this is going to be 2 pi or 0 here, and this is going to be pi here. So this would technically be 18 pi over pi. This is going to be 9 pi over 18, right? If you're breaking it down. Does that make sense?
Mm-hmm.
And so 5 pi over 18 is going to be roughly in the middle here, I'd say, right?
Yes.
Is that making sense or not making sense?
That makes sense. Yeah.
Okay, good. I'm like, oh. So back to here is the reference angle because it's got to be the shortest distance. It's got to be the acute distance of that angle. And so technically the angle itself is the reference angle because this is 5 pi over 18. And the shortest distance would be that. Because if I went here, that would be well over 90. So the reference angle is the angle itself.
Okay.
All right, so let's talk about negative 11 pi over 9.
And Miss Sparks,
Yes.
really quickly, when I have a thingamabob in the denominator for sine and cosine, do I need to also multiply that
Oh,
out?
yes.
Okay.
Yes. You have to rationalize the denominator always when it's a radical. Great question.
Okay. Thank
Yes.
you.
No problem. Good question. And I'm hanging out with you guys. So I'm going to work out number 18, Anna, with you. When it begins negative, it tells us we're going to roll in that counterclockwise fashion. Okay?
Okay.
So that means you're going to go over this way. And then if this is pi, that would be 9 over 9 here. Does that make sense? This would be 9 pi over 9. But if we're going in this direction, because we're going we're actually technically, we're going clockwise, not counterclockwise. So this is 9. And I'm going to go just a little bit past that, right?
Mm-hmm.
Because if I go all the way up here, I'm going to be at I'm adding because this would be, if I go all the way back over to here, it's going to be 2 pi. So somewhere in the middle, that's like 4.5. So that's why it's kind of ugly on this one, because you want to be right in the middle of those. But on this, we're just going 2 pi 9 past that. So the good news for that one is this is the reference angle, this piece right here. And so I would just subtract that 9 from that. 9 pi over 9. So my reference angle is 2 pi over 9. Does that make sense to you? Or not really?
Not really.
Okay. Okay, where did I lose you?
Well, right after like the 9 pi over 9, I got that. And then
Okay.
I don't know how to get the rest. And then I know where the 2 pi came from, but then the 90 degree, I don't know.
Okay, you don't. Okay, but you get where I got the 9 pi over 9.
Yes.
Okay, because technically it's always going to be pi over here. So what would that equivalent be with the denominator of 9? It's going to be 9 pi over 9. So remember that the reference angle is the acute angle. So the closest distance that you can get back to the x axis. So if this is my angle right here, 11 pi over 9. This is my angle right here. This is the terminating side, the terminal side of that angle is 11 pi over 9. So what is the difference between 11 pi over 9 and 9 pi over 9?
2.
2 pi over 9. So that's where I got it.
Oh, okay. That makes sense.
Okay. All right, good. That goes to there. And this would be 18 pi over 9.
Yeah, Miss Sparks.
Yes.
For when you're trying to find the opposite angle of a triangle and you have your hypotenuse as a rational number, like it's like 4√2. How do you do that? So I'm just confused.
So say that again.
When
Your
you are trying
hypotenuse. What is your hypotenuse?
four root
I can't
four
answer.
root
I
two.
can't answer a question that's on the quiz. So
Well, no, like okay, so like say you're trying to find an opposite angle and your hypotenuse is a rational number.
mhm.
How would you go about doing that? Would you have to
You'd square it. You'd still do a squared plus b squared equals c squared. You have to have one of the sides, right? And you have one of the and then you have the hypotenuse. You would still use the Pythagorean theorem, but what happens when you square a radical?
the root comes out of the radical?
Right. So if I have this and I
Yeah.
square that, I'm going to have 16 times 7 because root 7 times root 7 is 7. Does that make sense?
Yes, ma'am.
Okay. Now, Anna, back to number 18. So my coterminal angles, if you want to use the calculator method, to have, you've got one, they want you to have one negative and one positive. So
Okay.
type in 11 over 9 plus 2, math, enter, enter. And tell me if you get a positive number. I think you should.
Yes, I do.
Okay, what'd you get?
29 over 9. Wait, was I
Did you
supposed to
type in negative 11?
Oh, no, I didn't.
Okay. Because that sounded kind of high. Okay. So you want to type in open parentheses, negative 11 divided by 9, close parentheses, plus 2, math, enter, enter.
Okay, I got
That should be
7
7 pi over 9 is what you should get.
That's what I got.
And now type in open parentheses, negative 11 divided by 9, close parentheses, minus 2, math, enter, enter. That now you should get negative 29 over 9.
Okay.
Did that help with the math, enter, enter thing?
Yes.
Remember that? Huh?
Yes.
Okay, good. And did that help you? Are you understanding a little bit better about the reference angles? Just make sure that reference angle is less than 90 degrees. Or in this case, you want it to be, I'm trying to figure out, hang on just a minute. It's so much easier when your denominator is even to figure out what the other quadrantal angle is going to be in between, like 9, because 9 pi over 9 and 18 pi over 9.
Mm-hmm.
Let's see. 9. Oh, shoot.
Miss Parks, I'm just gonna go out and say it. This math is difficult.
Is it?
Yes.
Yes.
I think Anna could agree with me.
I do, 100%.
It definitely requires some thinking and some reasoning, definitely. And I'm trying to figure out how to not answer questions directly on the quiz, but still help you guys, like with homeworks and stuff like that. I wish there was another example. Was there any more examples on the on the like class notes, like number 17 or 18, Anna?
I'm not sure. I think
That I could go back through those?
I'm not sure. I think I'm good on those though. Like,
Oh, okay.
I understood it on the quiz, so after
Okay.
you explained it, so I think I'm good.
Okay. And I don't even remember what the ones on the quiz actually looked like. I don't even have it. I need to pull my copy of it so I have an idea of which ones to actually go to. Oh, at least it's on the quiz. That's numbers 14 and 15, right?
Yes.
Okay. And at least, yeah, and you did give the reference angle. Just remember to keep that reference angle less than 90 degrees, or in this case, it would be 10 pi over 10. It should be less than 5 pi over 10,
Okay.
the reference angle. Because the reference angle on number 18 is supposed to be less than 4.5 pi. That's why I was struggling with that over 9. You know what I'm saying? So, because it's half, so it's like 4.5 pi over 9. You need to make sure that reference angle, and obviously it is here. And that's why I was like, that's y'all, if I'm writing a decimal and a fraction, that should shut somebody completely down. Because that's the equivalent of pi over 2. Does that make sense? And that's what this is up here. So that would be 4.5 pi over 9 there from the homework.
Okay.
That's why you just want to make sure that's why I was trying to explain that, and I was like, oh, if I write a decimal and a fraction, they're going to hate me forever. All right. Are there any other questions? Because I can answer any questions on homeworks. I just can't answer questions on the quiz.
I think I'm good. Thank you.
Uh-huh.
Miss Sparks, I'm lost.
Okay. Numbers 20 through 28. You should rock on those for sure. Those were just like the ones we did in the beginning part of Math Lab. Anna, have you come across anything? Is she still with us?
Yes.
Mm-hmm.
Okay. Have you come across anything thus far on the quiz that was not on one of the homeworks?
I think we covered all of it. If like I had a question I asked you, so I think I'm good.
Okay.
Number 3, where you have to like you have to find the other side. Like how do you
Uh-huh.
I'm kind of confused how I don't know how to explain this. Like when it's 4 root 2 and then you have to square it, like I don't know how to do that.
Well, I can do another one. I can do, I can't do 4 root 2, but I can do
Okay.
another, just a completely other example.
Okay.
So if I have,
And are you talking about
two,
number 3 on the quiz?
Yeah.
yeah,
See,
if
that
I
was
have
confusing.
if I have 2 root 3 squared, I square the 2, right?
Mm-hmm.
And if I take root 3, this is just like when we rationalize our denominators, right? That gives me a 3, right?
Yes. Okay.
Does that make sense?
Yes, that makes sense.
And you should always write down exactly like when, oh, say, so like if you're given an angle and it says it's cotangent, that's the reciprocal of tangent. So make sure you're doing, you're getting that whatever it is, the reciprocal of. And you can use your notes for that. I think we did that on, so the reciprocal of sine is, why did I draw a blank? Cosecant. The reciprocal of sine is cosecant. The reciprocal of cosine is secant. So instead of it being opposite, instead of sine being opposite over hypotenuse, it's going to be hypotenuse over opposite.
Okay, that makes sense.
So just make sure you're using all of those. And you're, as long as, if you haven't done the homeworks, this is going to be a more difficult quiz.
Hmm.
The homeworks would definitely, because there's an example on each one. So if you have a question on the homework, let me know. Any questions on any of the homeworks?
Anna just left, so
Oh, she did?
yes, ma'am.
Okay.
It's me,
All
myself,
right.
and I now.
Okay. Any questions on any of the remaining homeworks?
Not on the homework. I just got a million questions times 2 on the quiz.
Well, what do you have your homeworks pulled out?
No, ma'am, I do not. I had them on
Okay, well,
I had them on my
I
computer.
would definitely have all of my homeworks pulled out. And then I would look for problems on the homework that are like on the quiz, because every problem that's on the quiz is on, there is a type like it on the homework.
Okay.
So that will help you to be able to know what to ask.
This is all very confusing stuff, Miss Sparks.
I mean, it definitely can be.
Yeah, so I have all the homeworks pulled out. Let's see. So if we skip to number, for on the first homework page, and we do number 11.
Okay.
So, like, can you walk me through that?
Yes. So if you think about sine 45, that's opposite. Sine is opposite over hypotenuse, right?
Yes, Matt. Would you just not type in sine 45 and that's it?
I mean, you definitely could do that. That's, I mean, for sure. And we've learned more since that time. But on this one, this is where you had the leg lengths were the same, and then your hypotenuse. I'm trying to go back to the actual notes so that you have a good reference. But which
What's
one?
the difference between finding the exact value of each trig function and
You know
giving
what?
the exact ratio for each function?
If you're referring to numbers 20 through 28 on the quiz,
I am. Yes, ma'am.
you would want to refer back to, because we were able to do it. We were able to do it on homework 1 because we identified those angles on the 45, 45, 90. And the reason why they do that is they want to introduce you to the idea that once you get into the unit circle, every single one of the things is going to be a part of one of those special triangles, either a 30, 60, 90 or a 45, 45, 90. But once we connected them into the unit circle, which we did on Monday and Wednesday, then you'll probably see that homework 4 is a better reference for numbers 20 through 28 on the quiz.
Okay.
And you would want to use your unit circle.
Okay. So.
Because sure, you could plug it in to your calculator, but you're not going to really give me the answer that I'm looking for because I'm looking for ratios from the unit circle.
Okay. So could you walk me through numbers 7 through 21 on the homework 4 then?
I did 7 through 21 at the beginning of math lab. So when we hang up or when we get off this, if you could just go back and watch that first part.
Okay.
Because I did the entire worksheet. I did every single one of them on homework 4 because I didn't know how far everybody got in class. So, but basically what you're doing in essence is looking at this and you'll pull your answer right off that.
Oh, sorry, my printer's just decided to make some noise.
So yeah. So I did that one.
So if I'm just going
So I was
to,
gonna say, let me see.
so when I look at
Numbers
the
8,
unit circle,
when you
it's just
yeah, I was
going to
gonna
tell
say
me that basically, so just going to number 7 on the quiz, it says, so you're,
you mean on the homework?
yeah, my bad, on the homework. Number 7 on the homework, you're going to be looking at the unit circle and you're going to be saying to yourself,
Sine 60,
yeah,
which is the y
well,
variable.
yes, ma'am.
And what's the y variable on 60?
3, or like root 3 over 2.
Okay.
So
Let's
that's
go back to what I have written down as my answer. Do you see it?
So all you're doing is just finding an angle and then just,
Yes, but don't forget if it's cosine or tangent, cosine is the x, tangent is going to be y over x, secant is going to be 1 over cosine, all of that stuff. And you will have to rationalize the denominator if you get a radical in it.
so you got sine equals y, cosine equals x, tan
Tangent.
equals x over y.
Yep. See, there it is right there. That should be on your unit circle. If you have your unit circle out,
Yeah, it's on there.
completed.
Okay.
Okay. See
So,
trig values at the bottom.
so and then when I have cot, sec, and then CSC, which,
It's going to be 1 over that. Like, so if it's if you have cosecant, that's going to be 1 over y. If you have secant, it's going to be 1 over x. If you have cotangent, it's going to be x over y.
okay, so could you walk me through a 1 on the homework 4 where you do tangent and cotangent?
Cotangent.
Yeah,
Number
10.
10.
Yeah.
Number 10. So y over x.
You
So
mean
I
x
have
over y?
negative root 3 over 2 and 1 and 1/2. And remember, when it's a complex fraction, the denominators cancel. So you're only dealing with the numerators, which leaves you with negative root 3 over 1, which reduces to negative root 3.
Wait. So it's cotangent 150. So you got a negative root 3 over 2 and 1 over 2. So you're just going to divide that out, basically?
Well, yes, but remember what I told you is that when you have a complex fraction and the denominators are the same, because you keep flip change, the denominators cancel each other out. So you're really only dealing with the numerators. So you can shortcut that. Remember, I talked about that in class?
Oh,
You
yeah,
can
yeah. I see what
shortcut
you're
it.
saying.
Huh?
I see what you're saying now. I see how you did it. That makes
And
sense.
so
Okay.
you're only dealing with the numerator. So you have negative root 3 over 1, which reduces to negative root 3. It's written down there. But
Yeah.
I actually walk the whole thing out in Math Lab. And I explain how they get the unit circle and all of that. And then there's a unit circle quiz on Monday. And I don't know if you got here for that or not, but I think Alex and Anna were both there, and I walked through how to memorize the unit circle with regard to degrees only, which is the quiz for Monday.
Okay. So, okay, that makes more sense now.
Okay, so numbers 18 through 28 on the quiz have to do with homework 4.
Numbers 8. Wait, you said 18 through 28?
Yes. And so you may want to watch the beginning part of Math Lab for those.
Okay.
All right.
Yes, ma'am.
And you'll find it to be very easy, I'm sure.
Okay. Alrighty. Well, I appreciate it.
All right. And take
Have a good day.
care.
Yes,
Have
ma'am.
a
You too.
wonderful Easter.
Yes, ma'am. You too.
Bye bye.
Bye.